Hello. Anish, are you able to hear me?
Yes, I can hear you. Can you hear me?
Yes. Hi, good morning.
Morning.
It just, okay, I think I can see your screen. Anish, would you want to switch on the camera or you want to keep it off?
Just bear with me. I'm trying to toggle between the screens.
So you should be able to, I think you might want to check. I think I can see your camera now. Perfect, perfect. So, yeah. Okay, nice.
I will change the virtual background.
And the background looks nice, by the way.
Thank you. I'll probably remove it just to. That's okay.
Yeah, perfect, perfect. I mean, with the background also, it looks pretty good. So anyway, so Anish, what we'll do is, I think your camera and your mic, everything is perfect. So what we'll do is, we'll get started sharp at 11. So
okay.
Just leave for 5 minutes and then we'll get started.
Super. I will be sharing my screen as well, if that's okay. I've got a presentation which I perhaps want to play.
Yeah, I'll just check how it is looking on the YouTube so that it should be like comfortable for the users to see both you and the presentation. If the presentation is getting masked off, then we'll switch off the video.
Okay, no problem.
Give me a moment. I'll just check on the YouTube and I'll confirm.
So I'm not sharing my screen right now, Sujit.
Yeah, it's being shared by somebody else. So I think that's done by the team here.
Okay.
So give me a moment.
Do you want me to email the presentation to you, if that helps?
Yeah, I think that'll work either way. So whatever is easier for you. You're on mute, Anish.
Okay, let me check if I can email the presentation because it's a fairly heavy file.
So either is we'll be sharing it through your screen itself, but in case if anything goes wrong, we'll take it up.
Okay, okay.
Yeah. Give me a moment. I'll just check for the YouTube.
It's 83 megs. I'm not sure if I can email the presentation.
You might want to share it through Google Drive in that case.
Let me try if I can. Can you help me with the email address?
So SUCHIT. I'll just type it in the chat.
That's fine. SUCHIT.
@INSAID.
Okay. .co. Okay. Right, I've just sent you now.
Yeah, I'll just check. So let us try to, can you share your screen once?
Sure. Screen share is on now.
Okay, it seems on YouTube, it's not yet updated. Okay, now it's updated, yeah. So yeah, you're going to do it as a presentation, right? Yeah.
That's right.
Now it's a presentation. Perfect. So I think, yeah, I'll just show you how it is looking on YouTube. So this is how it is.
Okay, yeah, I'm also logged into the YouTube. I think there is a slight lag in terms of, let me change the slide. Just change the slide.
Yeah, it'll take some time. There'll be a fraction of a delay, so that's okay. I mean, this wouldn't be a big deal. So that is why what we'll do is, Anish, is I'll pick up the questions, I'll filter them for you. So
Okay.
you can go ahead with the session as is, and we'll take up the questions only towards the end. And
Okay.
I'll narrow down the questions and I'll forward those questions to you as per the discussion.
Super.
Yep. So we'll start in another minute's time. I'll go off air, I'll go mute so that you can continue once I introduce you.
I've just noticed there seems to be a lag of at least 10 to 15 seconds of changing the slides on YouTube.
Yeah, I think that's okay. It shouldn't really matter if we go in a flow step by step. And in case there are any questions, I'll tell you in between. So you don't have to worry about the YouTube front. I'll take care of the YouTube front.
Okay.
You go as per your flow, the regular flow.
Okay, no problem.
It's 11 o'clock. Yeah. So, hi friends, good morning. I hope all of you can hear me loud and clear, and give me a quick yes on YouTube if you're able to kind of understand what we are talking here. So I'll just wait for your responses on YouTube Live. Okay, yeah, I see all of you can hear me clearly. So great. So I'm really glad to kind of welcome our friend here, our mentor here, Mr. Anish. So Anish is a really popular face when it comes to the world of data science, machine learning. He happens to be one of the top 100 influencers in terms of machine learning. So Anish has a pretty huge career. I mean, it's been almost 2 decades, and correct me if I'm wrong, Anish here. So it's almost like 2 decades that you have kind of covered your journey in the space. Plus, you have really fascinating background, like you've been actively involved in the finance space. And if I'm not wrong, you've also done some component in the legal space as well, right? So without any further delay, friends, let me hand it over to Anish. Anish is going to take it over from here. So over to you, Anish. Could you please kind of help our audience here by introducing a little bit about your background, and then we'll take it forward with the talks that you have for all of us today. Thank you, Anish.
Many thanks, Rishit. Welcome and to all the attendees for this particular session. Perhaps, Suchit, to answer your question, 2 decades is something which I don't really resonate much because it makes me remind of my age. So I stay away from that specific number.
You look really young.
Oh, thank you. So by way of background, as Suchit said, they are almost 2 decades of what I've spent of my life in my professional journey. Started way back in 2001 and right now in 2020. Never ever thought that we'll witness something as as precarious or as difficult period as COVID that actually taught us a lot of things. We always believed that disruption is something we should stay away with, but right now we are in a forced disrupted setup. So yes, my current engagement is with NatWest Bank, which is a British bank. I've been with NatWest for close to 6 years now. Before that, I was working with a British law firm called Clifford Chance, worked with them for 3 years. And then prior to that was working with another British organization, which was Vertex, worked with them for close to 8 years. And started my career at a point in time when the outsourcing and offshoring industry was riding. And I too thought that I should capitalize on that opportunity and started with a startup in 2001. Data and analytics, I guess my first stint with data and analytics was in 2006. That's when the overall regime of business intelligence was picking up. Number of organizations were trying to ride on the wave of what we understood as BI, or they're trying to harness the power of data. But it wasn't as significant or as important at that particular point in time for only one reason, because the availability of data always posed a big challenge. But if I compare 2005 versus 2015 and 15 versus 20, I think we are in a completely different ecosystem altogether. We don't really have to worry about availability of data. It's available in abundance. That actually means that if you've got information, you've got a power to analyze and try to understand things with a much better perspective. And I know for all obvious reasons, if you look at what's currently happening in the world, the COVID-19, I'm so sure if we did not have the data available, the power to harness data, the number of clinical trials which are currently happening and the success rate of the clinical trials and the endeavors and the efforts of the big pharmaceutical companies to come up with a vaccine for COVID-19, it wouldn't have been possible with such an ease as it is now, because we've got systems, we've got the techniques, we've got, most importantly, skills to harness data. All right, so that very neatly brings me to today's topic, which is data science. And when I was having a conversation with Sujit, we did brainstorm on a number of topics, what should be the right subject for us to talk about, and we couldn't really discount data science at all. One, for all obvious reasons, this is currently the hottest topic which students are talking about, professionals are talking about, and it's not just a regime which is in a specific country, but it's a global phenomenon. It makes sense for us to understand data science. It makes an all obvious sense for people to start, getting into the streams of data science, build the career into data science, because data science isn't going anywhere. So what I'll do today is, before we get into the aspects of data science, I'll spend a bit of time around what exactly is data, because I think it is important for us to understand what data is all about. Then we'll get into the data science side of the story, what is data science. We'll also talk about a few of the use cases in data science, what are useful, and few of the interesting use cases, how companies or industries or verticals are harnessing the power of data. And then we'll also talk about trends, and towards the tail end of the session, I'll be more than happy to take any questions if there are any. So let's start. Essentially, if in case we talk about data, what exactly is data? Data is, and if I was to use the definition of data as defined by Sir Tim Berners-Lee. Who is Sir Tim Berners-Lee? He is known as the inventor of World Wide Web, and I had an opportunity to meet him a few years ago, and trust me, it was a great interaction. So Sir Tim Berners-Lee explains data as a precious thing which will last longer than systems themselves, which essentially means that data is here for long, it's here forever. Which means that if we've got data, not just for today, but for the past, and if we can harness the data, we can even have the potential to forecast what perhaps we'll see in next years to come. So going back to the very, very basic definition of what data is. Data is a plural for the word datum, which is apparently a Latin word. And datum is defined as a single factual or a single entity or something that is a single point of matter. So the way we define data, it is a quantity, it could be an information, it could be a graph, it could be a measurement, it could be an observation, it could be a fact, or it could be a number as well. By very means, when we're interacting right now over this YouTube session, we are also accumulating a number of data points. And what could those data points be? The number of attendees could be a data point. The number of words that I'm speaking could be another data point. The duration of the session could be another data point. The number of questions which come could be another data point as well. So it's all about our ability to tap or harness the data is what we can beautifully articulate into and neatly get into an analysis side of the story, which also is known as analytics or data science today. Whenever we talk about data, it is also important for us to understand the 5 key characteristics of data, which are the 5 V's of data, which essentially are velocity, volume, variety, veracity, and value. So what all of these means? Velocity essentially means the speed at which the data is emerging, is originating, and the changes which are occurring between the diverse data sets. When I say the speed, it essentially means the number of gigs and gigs of data that actually gets generated every minute. And I'll talk about it in the next slide. The volume of the data, the amount of data that gets generated, every minute, every hour, every day, and every month. The variety of data. If we talk about the variety, it's a combination of structured and unstructured data. There are a number of types of data which gets generated. If in case you're using an app on your mobile, which is a banking app, you're actually generating data which is quantifiable, i.e. the transaction that you're making. If you're making a purchase on Amazon, the sale's on right now, by the way, you actually are generating both quantitative and qualitative data. How? Quantitative data in the sense the number of products that you're buying and the value of the products. And the qualitative data apparently is the feedback that you perhaps may be placing as a part of the review mechanism which Amazon or any specific shop or website or service may have. The veracity of data, which also means the accuracy of data. Given the data is generated by the end user itself, the reliability on the data is much better as opposed to previous instances. As an example, historically, the way data was accumulated was it used to be gathered basis market research or surveys. I'm not sure if you may have experienced at a certain point in time, but I have for sure. If you visit a shopping mall, you may see a guy standing right at the entrance or in a specific store with a form, with a questionnaire in hand, willing to ask you questions basis your shopping patterns, your buying patterns, the time of the day. And all that data is aggregated in a form of paper and then transported into an Excel, and that's when the analysis used to be done. Given there used to be a lot of manual intervention, it essentially meant that there could be a scope of human error. But right now, Arogya Setu as an app, for example, it taps your data real time. You don't need to ask anyone, are you ill, are you unwell, how safe are you? Intuitively, with the help of technology integration, it actually helps to warn an individual the safety aspect around the COVID-19. And then comes the value of data. Having access to the data actually means that, and if a company has the right mechanism to tap the data, it is immensely valuable. And data today is understood to be a commodity, and you need to buy and you need to manage a commodity. Let's talk about two organizations which actually are pioneers in tapping the value of data. I'll first talk about Uber as an example. Uber is understood to be the world's most valuable cab service provider. The beauty around the service is Uber doesn't own even a single taxi. They do not own even a single car. All Uber is doing is they're trying to tap the value of data. What are the data points they're trying to tap on? The first is the request from a passenger, the individual who needs to hire a cab, the pickup address. The second is availability of the driver, the location of the driver. And the third is the destination. So all Uber is doing is acting as an intermediary between these three data points and providing you a service. The next example that I can perhaps quote is Amazon as an example. Amazon doesn't produce products. They do not have any manufacturing setup. All they do is they act as an intermediary between a buyer, that could be me, you, anyone, and a seller who is trying to sell a specific product or a service. And all Amazon is doing is acting as an intermediary, offering a platform. That's about it. And look at it. Both these organizations today are one of the leading organizations in their specific vertical. So let's have a look how big is big data and how big is the data today. If you look at the slide, in 2019, every minute, there were close to 188 million emails which were sent every minute. Uber booked almost 10,000 rides every minute. There were close to 277,000 stories which were posted on Instagram every minute. And likewise, so if you look at other aspects of Skype as an example, users made 231,000 calls every minute. So each and every aspect is a strong data point. It actually indicates what is the volume and the variety of data that gets generated. Skype phone calls is a voice data. YouTube videos is another sort of data. Instagram post, qualitative data. Bookings on Uber, Amazon's, or any shopping portal is a quantitative data. That's the speed and the variety with which the data is emanating every minute. And look at the power if in case we tap all this information, the meaningful analysis that we can actually draw. As an example, let me bring you back to the example of today's session. If I was to draw a meaningful analysis of today's session, the best way I would perhaps look at it is what are the specific locations from where individuals have joined today's session? What is the gender? What is the education qualification? What is the interest? And then perhaps I can also do sort of a sentiment analysis based on the feedback that I get from such session. Now, if I was to design a future session, I can actually host a more targeted session. Let's say as an outcome of today's session, I understand that there were majority of individuals who joined from Bangalore as an example. The majority of them were postgraduates, and by means of feedback, they felt that the contents around data science were relevant for them. So my next session perhaps could be specific to colleagues or individuals in Bangalore. I can reorient the content which is actually more tuned to a postgraduate or an MBA sort of stature from a data science perspective, and perhaps, and I can add more examples or more knowledge or information around data science. So that's how, that's a very simple example of how meaningfully you can harness the power of data. Let's now talk about data science. And one of the things that I always talk about is a question, which is, what profession did Harvard call the sexiest job of the 21st century? And no other profession, it's a data scientist. For all obvious reasons, it's not just about the pay. Number of people do query and do ask me, I understand, I've heard, I've seen that a data scientist gets paid really well. Yes, that's a fact, but it's not just about the amount that you earn. It's also about a strong mix of aptitude and attitude. When I say aptitude, data science requires a lot of additional skills that you need to be champion at. And likewise, from an attitude perspective as well, you need to have a very strong eye for detail. Unless you have that sort of attitude where you can really demine the data or mine the value of data, it doesn't make any sense. Let's talk about a definition of data science, and I'll give you two definitions, and I'm picking this from a very simple analogy of the famous movie 3 Idiots. So if I was to give you the very first definition, which is a complex definition of data science, essentially data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structural and unstructured data. Data science is related to data mining and big data. Now, if I was to ever scare people away from data science, this is a definition that I would perhaps use where they would end up feeling, oh God, it's too much. Maybe I can think of some other profession. But let's look at a simpler aspect of what data science is. It's simply the art of uncovering the insights and trends in data. As simple as that. And essentially, that's what data science is all about. Whenever we talk about data science, I think, as I said, it's a mix of both attitude and aptitude. And that's the reason I've got this Venn diagram on the slide. There are three key aspects. The first is the computer science and the IT, the knowledge that you possess. The third is your skills around maths and statistics. And the third is domain and business knowledge. Now, if you look at the Venn diagram, let's look at the first two circles. If in case you've got you've got an education background, which is in computer science and IT, and you've got a good knowledge of maths and science, that actually means that you can be good in machine learning. You cannot be good in data science. If you look at the left circle and the bottom circle, which is the knowledge, which is your academics around computer science and technology, and you've got a good domain and business knowledge, i.e., when I say domain and business knowledge, you could be an expert banker, you may have experience in the retail sector, you may have experience in logistics, travel, or e-commerce. If you combine them, you could be good in software development, because given you've got technical background, you know how the industry works, you can actually design softwares or applications using agile methodology to ensure that the overall efficiencies are achieved. Let's look at the right circle, which is maths and the business knowledge. If you have these two, that means you could be a good researcher, because basis the knowledge that you have in the business, you've got data points, you're good in math and statistics, you can research on the subject in a better way. However, now to be a data scientist, you need a mix of all three of them. That means you need to have an academic background around computers or IT. That's one. The second is you should be good in maths and statistics. And the third is domain knowledge is very important. Now, let me also explain that when we say you need to have a computer science or IT background, that doesn't necessarily mean that you need to have a postgraduate or a graduate degree. It means that you need to have an understanding of the coding aspect of the data. SQL is the base language around coding. If you know SQL, I think you made a good starting point, and then you can progress further. You don't need a specific degree, but you need to have a knowledge of the coding. The reason we need to know coding in data science is because big data is all about huge lines of data, which at times, or rather in majority of times, is not possible to be managed, which you can manage in a limited number of rows in Excel. That means you need to host your data in big databases, in enterprise data warehouses. And to talk to the data, you need to actually code to extract the data out. From a maths and statistics as well, there's no necessity that you need to be a graduate in statistics or a postgraduate in maths or statistics as well. There's a difference between knowledge and expertise. You need to have knowledge of basic concepts of maths and statistics. Trust me, there are a number of concepts that you learn on job. You cannot be an absolute champion. There is no expectation that you need to be Aryabhatta or maybe Shakuntala Devi to be pioneer in data science. What really plays an important role is the domain and business knowledge. Let's say if you are a champion in computer science, you're a champion in maths as well, but you lack the knowledge of the business. There's limited that you can do to actually find a solution to a specific problem. And let me give you an example, which is a very popular example of a Titanic case study that we normally put across to candidates who probably want to get into the career of data science. So what's the Titanic case study all about? Let's say if I was to give you a business problem, which is if I give you the data bank of all the passengers who are on board the famous ship, that's Titanic, and the data set of the passengers include the name, the gender, the port of boarding, the port of final landing, the ticket ID and stuff, and the value for which they purchased the ticket. Basis the data set, I challenge you, can you now predict the fatality rate if in case Titanic was to sink? How many people would die if this ship will sink? An obvious response would be ridiculous. How can I actually basis this information? I can actually define how many people will die. There could be an element of unconscious bias here, where there could be certain set of individuals who may feel that, okay, given I've got the gender as a data point, I can predict that there could be more male survivors versus female because they feel men are more active than women and stuff around that. Well, that's not right. If you actually take an opportunity to study each and every metric that you've got access of, one of the unique attributes about the passenger ID that was issued to each passenger of Titanic was shorter the passenger ID, nearer that passenger would be to the lifeboat. It essentially meant that if you had the right knowledge of the specific optics around the database for data bank for Titanic, it would have been easier for you. That's a very simple example of how important it is for you to understand and know the data in the right manner. There are many questions around what is the difference between various aspects of what is the difference between data science, what is the difference between machine learning, artificial intelligence and stuff. And that's why I brought this slide. So data science essentially is a need of entire analytics universe. It's the branch that deals with data, and there are different operations related to data, which would be data gathering, data cleansing, data subsetting, offsetting, manipulation and stuff. And then comes the second bit, which is the machine learning. So machine learning essentially is a combination of machine and data science. It utilizes data science techniques. The third is the neural network or the neural language programming, which essentially is simple neural network, conversational neural networks, and it's primarily utilized for object detection and image and video, speech recognition, and natural language processing and other understandings. And the fourth is an artificial intelligence, which apparently is a whole universe. And I would say data science, machine learning, NLP actually forms a subset of the overall AI universe, which actually means AI empowers machines to take decisions on their own. Basis data. There are questions wherein or people feel that, okay, if you empower a machine using AI, can the machine think for itself? Well, the fact is, yes, but only basis what you train the machine on. It cannot be the fact that you're training machine on a specific or other predicting the weather conditions and you're asking your future from that machine. That's not possible at all. So what essentially a data science team looks like. There are four key roles. First is a data scientist, responsible for preparing data, engineers the features, the most valuable skills are training the models. The second is a data engineer, responsible for acquiring the data, build data pipelines, ensuring data interacts with multiple data warehouses. It could be Teradata, it could be Hadoop, how data sits, what's the architecture of data. The third is a data analyst, essentially who assists the data scientist in preparing the data. Now there's a very clear differentiation between data analytics and data science. And people normally get confused, what should I really build my career in? Should it be analytics? Should it be data science? Well, they are very, very different. So what's the difference? Data, so let's say if you've got big set of data to an extent that, let's say if you've got a data bank of last 10 years of all the transactions which are made on Amazon as an example, The role of a data scientist would be to find a problem using that from that data set. Is there actually a problem if you were to study the last 10 years transaction history of Amazon? What could be a potential problem? Are the sales limited to a specific sector? Are the sales limited to a specific geography? Are the sales, not being uplifted, even though there are specific marketing campaigns which are run by Amazon? That's the role of a data scientist. The role of a data analyst is to actually find a solution to that problem. Let's say a data scientist comes back with a hypothesis that, in my view, basis the data that I've studied, one of the biggest problems which Amazon's facing is there are no sales in northern part of India. The role of a data analyst would be to find a solution. How should we be uplifting the sales for the northern part? That's a broad-based difference. And the last role in data science is the application architect, which actually helps in deploying and maintaining the models which are in production, ensuring that the codes are right, there are no outliers, and most importantly, there are no biases as well. What's a typical data science project team looks like? So the first, as I said, role, data scientists and data analysts will understand the business objectives. The next phase is procuring the training data, which essentially is done by a data scientist, data engineer, and application architect. The third phase is preparing data and building new features, which essentially is done by the data scientist and data architect. And the fourth phase is the training the models and then deploying the models as well, which is the role of a data scientist and an application architect. And then comes the last phase, which is updating the models, which collectively can be done by all of them, depending on the stage and the level of updation that's required. Let's look at a few of the intriguing applications of data science in today's parlance. The first one is agriculture. Now, people may not be really aware of how significant or what strong role data can play in agriculture. India being an agriculture-driven economy, there's a lot that can be done, using the data. So let's say if a farmer has got access to the data of the soil, i.e. the type of the soil, the volume of water that's available, at a specific point in time in a year, the minerals from the farms, and if everything's stored in one centralized system, it will be much better for a farmer to harness the potential from that soil. To an extent, a farmer can also understand the yield that the particular farmland is producing, and can also understand the time, basis the time of the year, how much is the yield produced. Next year, basis the data, there could be a better investment in the seeds, better investment in the associated fertilizers as well, and other resources like water and electricity, and overall experience of farming can be optimized. I now have a quick video which actually talks about the agriculture, as how data sciences or AI is propelling the agriculture and AI space. The video courtesy is IBM. I'll play this video for you now.
With over 50% of the total population engaged in agricultural activities, agriculture is the backbone of India. The 1.3 billion people in the country survive and thrive owing to the crops we grow. With sufficient support, agro-tech ecosystem can be transformed to attain prosperity. IBM Research is developing new innovations leveraging technologies like artificial intelligence, machine learning, data analytics, and cloud to drive the transformation and future of the agriculture sector. Our research supports agriculture by helping to increase farm productivity, monetizing crop output properly, reducing the volatility in production, and giving farmers easy access to capital. Technologies like remote sensing, AI, IoT, and visual analytics are being used to produce crops more sustainably and increase productivity. IBM's AI-powered precision agriculture solutions include advisories and insights to help improve farming outcomes and enable organizations associated with agriculture and food value chain to use data-driven decisions. These solutions combine remote sensing data, machine learning, and advanced analytics techniques to provide agronomic insights that help in efficiently managing scarce groundwater, optimizing the timing and amount of fertilizers and pesticides used, and timing their harvest to maximize yield and minimize wastage. Crop health monitoring, remotely monitors a piece of land in near real time and generates alerts to the farmers in case of any crop stress. Soil Moisture Service estimates the soil moisture at the root zone level, up to 1 meter depth below the surface purely through remote sensing, and identifies the irrigation needs for the specific crop. Crop yield estimation provides sowing advisory and remote sensing-based yield forecasts to help farmers estimate the yield from their farms before harvesting the crop. Plant pathology predicts pest and disease risks 7 to 14 days in advance based on hyperlocal weather data. This solution gives early warning signals that can help in minimizing the crop losses. While various private and government institutions in the country have programs and provisions to help the agriculture sector, the main challenge is that the grower is unable to get timely compensation for the losses because yield loss estimation exercise is still primarily a manual activity requiring significant human efforts. Crop insurance is an AI-based solution that considers rich weather and remote sensing data to estimate yield loss, detect potential frauds, and analyze risks, while insuring the crops, creating a win-win situation for farmers and insurance companies. Cognitive credit scoring uses basic farm-level details that affect yield and farmers' income to address the traditional approach of evaluating a farmer's credibility to avail finance. With many more such solutions, we aim to increase productivity, to be more in line with world averages and impact the GDP positively. In our labs, we're building cutting-edge solutions to transform the future of agriculture in India.
Super, isn't it? So what we only understand as a plain, simple farmland, maybe we see a few farmers on the farmland. I think it's much more than that. And that's the power of data. Let's talk about another application of data, which is the recommender system. One of my favorites. For two reasons. One, the power of recommender systems ensures that an organization can provide a personalized service or a product to the customer. That's one. The second is because the service is personalized, the amount of resources that an organization requires to provide that particular product and services are much minimal. That means the overall operations are more optimized. The two key examples of recommender systems, one of course is Netflix. I'm sure you would know each time you log into Netflix, you'll see a bar on your Netflix account which says based your viewing history or recommended for you. How does Netflix essentially does that? The way it works is Netflix, each time you're watching a movie, every movie has its own metadata. What is the metadata? The background data which sits around that specific feature. And that could be the genre, that could be the duration, that could be the language and stuff. Now, what that means is each time you're viewing a specific series, the Netflix account is registering your interest. And next time, if in case you log in, it matches your interest with other available series or features in the library and recommends. That's one. The second best use of recommender systems is on the shopping portals. Amazon, as an example, you may have seen based your buying pattern, Amazon also recommends that this is what you can also buy. Now, the recommender systems work on two tangents. One is a user-based and second is an item-based. The user-based means that it's not just about you as a user who is buying, but other users of who may have similar characteristic as yours, i.e., other users who may be from the same geographic location or who may have similar buying potential. Amazon would recommend those sort of products as well, what they are buying. The second is an item-based. The specific item that you're buying. Let's say if you buy an iPhone, the recommender system may recommend that you can also buy the iPhone cover, or you can buy other associated accessories related to an iPhone as well. Now, if you were to map this overall ecosystem of recommender system into the banking, it actually would give a very good experience to a customer. And that's why I've got another video which actually talks about, let's assume a recommender system is baked into the way we bank and our banks does it. How does it work for us? So let's have a look.
Can you imagine the intelligent banking experience on a vacation? While Ted is enjoying his vacation, a bike, Harley, passes by, catching his attention. The bike has been Ted's dream since school. Ted takes a picture and uploads it on his social media account. Instantly, Bank's intelligent software picks up Ted's interest in this bike, analyzes his post on social media, his sentiment, his conversations about the product, and after analyzing his spending patterns, the bank offers a pre-approved bike loan along with information on the best dealers around, their discounts offered, and the color options available, all on the go. While Ted is and offers him the best deals on bike accessories at a nearby store. And this is not all. Before the vacation ends, the bank delights Ted by offering him free airline miles and complimentary hotel stay to plan his next vacation. Imagine millions of customers like Ted for a bank like yours. The intelligent software enables you to continuously track millions of social media conversations to engage, interact, and offer a futuristic banking experience to your valuable customers. Place, time, or medium no longer matters. Engage your customers. Delight your customers. NewGen products help you do just that by connecting systems, processes, people, and things of your business.
I wish I could be Ted. Next time I buy a bike, I get a free holiday as well. Amazing, isn't it? The third interesting use case, or rather the fourth interesting use case around data science is the aviation bit. Now, airline industry, as you would know, has always been under the pressure of increasing or changing fuel prices. That's one. Cutting edge competition, customer service, and other logistics costs as well. If aviation industry was to use the data, and or rather they're using data science or data in the right manner, they can actually predict when is it the fuel prices would rise, and that means that they can even tweak the cost or the tariff that they're offering, or ticket tariff that they're offering to the passengers. That's one. The second, airlines can also use data to optimize the route planning as well, just to ensure whatever flight path a specific aircraft is taking, the routes optimized with a view of there's a lower expense or the fuel burn is less. I happened to interact with one of the test engineer or test pilot of one of the airlines, and I also understood that airlines are even using the data point to understand the best, the landing path for a specific aircraft, because landing and takeoff is something that actually utilizes majority of the fuel, and it's all about the information that they have in hand. Another way the airlines are also using the data is trying to understand the weather patterns. If a specific country or on route, the weather patterns have been standard or have been constant, which actually means that there could be a specific delay in the journey, they may perhaps optimize the route to ensure that there is no further delay. And the last bit is the recommender systems can also be embedded in aviation to ensure if there's a specific route which is actually witnessing maximum traffic, what is the best way a specific service can be bundled with for the passengers, so that they can not just enjoy a faster speed of booking, but also enjoy additional services as well. The last bit is speech recognition, one of the most famous and popular aspects of data science. What essentially is a speech recognition? It's an ability of a machine to recognize what we are talking and then translate that speech into text and then convert that text into a meaningful action. Amazon Echo as an example, Microsoft's Cortana as an example, Apple Siri as an example. Today, in the world of COVID-19, I think the speech recognition would have far more greater role to play, because it's a contactless medium. You don't really need to touch a device. You don't really need to touch the switch. All you do is just give a voice command, Alexa, switch on the phone, switch on the tube light, switch on the geyser. That's about it. Speech recognition plays a significant part. And it's not just about the voice commands, but it's also about their ability to act for future tasks as well. So as an example, you can always tell the voice assistant to book an appointment or to set up an alarm for a specific time, and there you go. And that brings me to the last bit, which is a quick video from Google on what they did around the speech recognition.
Hi, I'm calling to book a haircut for a client. I'm looking for something on May 3rd.
It turns out a big part of getting things done is making a phone call. We think AI can help with this problem. Let's say you want to ask Google to make your haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like, what service is she looking for? Just a woman's haircut for now? Okay, we have it 10 o'clock. 10 a.m. is fine. Okay, what's your first name? The first name is Lisa? Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day. Bye.
Interesting, isn't it? And last bit is the delivery logistics. There are a number of supply chain and delivery logistics organizations which are tapping the power of data to again ensure the overall turnaround time in terms of delivering a specific shipment is least. That's one. The second is the cost of resources is minimized, which is very, very important for any organization. And using data science, these companies have discovered the best routes to ship, the best suited time to deliver, the best mode of transport to choose, thus leading to cost efficiencies and many more to mention. When we say the best suited time to deliver, it's always understood that at a specific point in time, there could be delays owing to the traffic, there could be delays owing to certain conditions, other conditions as well. So if you've got all those data points in hand, you can actually ensure the overall shipment is traveling much faster. And it always makes me wonder the level of optimization or the speed at which Amazon today delivers. You order a product and there are instances where the product's even delivered in less than 24 hours. And the way it's possible for any such e-commerce or online merchant is basis a combination of the optimizing delivery logistics, embedding recommendation engine, and the algorithms which actually predicts the probability of a product which perhaps would be purchased by a customer in next 24 hours. And what these organizations does is they actually keep that product, which is the highest probability rate of purchase, in ready to ship mode, which actually means that they do not really waste time in preparing or packaging that product. It saves that time and just delivers and fulfills the promise that they've made to the customer. Let's now talk about the data science trends. What essentially are the trends in data science? The first is the Python, which actually is today one of the most acceptable languages for any data science project. Now, there are three key tools which are currently in use and practice across the globe. These are pioneers. First is Python, second is R, and third is SAS. The key broad-based difference: SAS is not a language. SAS is a tool which is based on the principles of SQL as a base coding language. R is a language. There is another tool which is RStudio if you want to practice R. The third is Python. Python is both a language and a tool for you to work on Python. You need Anaconda or any other application to work on. Python has emerged to be the most agile and most flexible language tool today for many organizations. I would recommend, if you do a quick search on Google, you will understand the number of use cases which are currently available on Python. Use cases by companies like Netflix and other Ubers. How are they using Python in their current day-to-day operations? The best part about Python is it's not just about a data analysis or data science tool. It also helps to integrate the APIs designed in Python with the real-time environment, which essentially means that you're not just analyzing the historic data, but the language also has the power to analyze data real time and make changes in the front end basis the way customers or consumers are interacting with a specific system. The second is AutoML. Now, automation and machine learning is how we call it, or automation data science. This is essentially a mix of automation and the coding side of the story. There are people who have always come to me and asked, with auto ML, do you think there will be job losses? We may not need many many individuals who've got machine learning or data science skills. Well, the answer is no, that's not the case. Auto ML is similar to the way automation has worked in many other areas of the business. And let me give you a very simple example. The first example, and the example is, there was a point in time when there was a lot of nervousness in the overall banking regime when ATMs were launched. Because people felt that if the banks were to deploy ATMs, there wouldn't be a requirement of a cash teller. The role of a cash teller at bank would actually not be required. It's been years and years since the first ATM was set up in India. Even today, in every branch of the bank, we see a cash teller. Because while there's an automation that can be achieved for a particular scale and size, we would still need human intervention, not just to maintain and manage what's been automated, but also to enhance the capability of the automated solution. The third key trend is the natural language processing, or the conversational analytics, as we understood previously. The example that we saw of the Google video is a bright example of natural language processing and conversational analytics. The machine's conversing with humans. And NLP is all about trying to understand the data points which have been spoken or what's available in the system, derive a meaningful analysis, and then come up with the outcome. Now, there's another side of the story, which is NLG, which is natural language generation. That's also picking up pace. Now, what essentially is natural language generation? It is the ability of a machine or a software to generate a script or a script or a tone basis what is witnessed or basis what's being fed. I'm not sure if you had an opportunity to look at a few videos which are doing the rounds on YouTube and LinkedIn recently, where there's someone who has used the NLG concept to actually design the commentary of a cricket match. So the machine very intuitively looks at the way the batsman swinging the bat and hitting the ball, the direction in which the ball's going, and if the ball's nearing the boundary, the system prompts, all right, what a shot, it's nearing for a 4 or a 6. That's the NLG side of the story. Then comes supersized data science in the cloud. Now, with megs and megs and gigs of data which is being generated, there's an ever-growing need for engineers or individuals who've got good knowledge of cloud. To an extent that every organization, every leading organization today in the technology space has created solutions in the cloud. Microsoft Azure, Amazon's AWS, Google Cloud is another aspect. IBM has their own cloud aspect as well. And it makes sense, as opposed to investing in a lot of investing in the on-site infrastructure, setting up storage systems. Organizations today are leveraging on cloud. One, the security on the cloud is much better than having an on-site premise storage. The availability of data 24/7, agnostic of location, is something that aids. That's the second bit. Third, ability of cloud to save gigs and gigs of data and making it accessible anytime is also aiding the cloud adoption as well. And then comes a diminishing model around biases and discrimination. Gone are the days when there were big use cases or news headlines doing the rounds that this company has designed a machine learning or a data science based solution, and that algorithm is actually leading to a lot of biases. Well, we now have very few such cases, for only one reason, because there are more checks and balances in place. There is a pre-development, in development, and post-development checks which now happen, which ensures that the outcome or the use cases are much more meaningful. There are no biases or discrimination, which algorithms are talking about. Few of the most interesting and popular cases are the Amazon's algorithm, which they used, which they designed to for the recruitment process. That was one. There's another use case around. Around the overall justice system in the US, wherein from a law perspective, there were algorithms which were written, which actually defined the probability of someone committing a crime, and then if someone's committing a crime, passing on a sentence as well, basis the historical data. Well, they were initially incorrect, but everything seems to be working fine now. So that very neatly brings me to an end to my today's presentation. Switch it over to you. If you have any questions, I'm more than happy to take. Thank you.
Yeah, thank you, Anish. I think this was really a very interesting talk, and especially the examples that you gave, those are fantastic. So if I've done my data science correctly, I'm pretty sure you're a movie buff and you love to watch movies. So are you updated with Shakuntala Devi as well?
Oh, yes, very much. Absolutely.
Okay, so yeah, it looks like I know my data science to some extent. So Anish, we do have quite a few good questions here, and let me start off with the first one, which is now when it comes to kind of data science and AutoML that you suggested, which kind of leads to us thinking that jobs will be lost. Now, technically, on an analogy that you gave for ATMs, right? In ATM perspective, obviously the number of tellers reduced, right?
Yeah.
Now, how does this then sync up? Because there are human jobs that got lost, right? Now, how would you convince people that this was actually the best way to go forward?
So the way I would look at it is essentially, if you look at the overall ecosystem of AI, machine learning, and NLP and other aspects as well, there are obvious. There's an obvious nervousness which talks about the death of data scientists and will auto ML replace them. And this actually came soon after Google and Microsoft introduced their auto ML services to the world. The popularity and interest in these services really skyrocketed. And there were organizations and there were analysts and review organizations which reviewed the auto ML, compared the platforms available, and they tested against the real data scientists to answer the question, which is, will auto ML replace data scientists? So the fact is, one cannot introduce auto ML without mentioning the machine learning project's life cycle, which essentially includes data cleaning, featuring other features which include selection and engineering the data, the model selection, the parameter optimization, and finally the model validation. All these would still need a human intervention. The auto ML side is just about the coding side of a specific phase in the overall life cycle of machine learning. As advanced technology comes into play, the traditional data science projects perhaps would still need to incorporate a lot of manual processing which would remain time consuming and repetitive, and would need a lot of manual intervention.
Absolutely. So I think from the bank analogy perspective, what we can say is obviously with the introduction of ATMs, tellers went below what was supposed to be, but then it was good in some way, right? The banks optimized their work. Instead of paying more salaries, more payments for the infrastructure, they are giving back that money to the customers. You have invested your money in the banks and the banks are returning you that money. So it's more of an optimizing the entire system and getting the best out of the system, right?
Correct. And the way to look at it is repurposing the roles of the tellers as well. I may not need two tellers as an example on the front job, but the second teller that I had, I perhaps have an opportunity to repurpose the role of the second teller to maybe sit at a different desk.
Yeah. So I think that totally makes sense. Like repurpose them for some better activity instead of just doing a manual kind of work, which can be easily taken on by machines. So very nice. So Anish, we do have a little less time, but I'll try to kind of ask you as many questions as possible because there's like plenty of them. So the second question, let me jump to you as the director of data analytics and data science at NatWest. How do you kind of look at the perfect candidate, or not, let's say perfect is a wrong word, but let's say a good candidate who would fit in well in your team. So what are the skills? What are the attitude levels? What kind of attributes do you look out for in a person? And this I would ask from both a non-programmer perspective and a programmer perspective. Obviously, having both of them covered the data science journey.
That's a good question. Much needed. So, in today's context, and I can talk about my experience, which actually resonates very well with many other colleagues or peers I've spoken to in the data analytics and data science fraternity. Today, the focus is less on the technical side. The focus is more on the industry knowledge and ability from a logical reasoning perspective. For only one reason, because let's say if I have an analyst who has an average technical skill but has a good logical reasoning, that analyst would perhaps be more suitable for me, because if someone gets stuck on a coding or a specific code, it takes quick 5 minutes to search that code in Google and get the right code and just get your ball rolling. However, Google will never ever come back to you, or you can never find a solution to a problem in Google, i.e. which table needs to be matched with which table. That's one. The second key skill that we look at is the storytelling part, which is, even if I have a good data scientist or a good data analyst, but if you are unable to draw the story of your findings into meaningful presentation and you are unable to communicate that to the stakeholders, I think I have a problem. The third is the communication skills, which is very, very important. Given majority of organizations today have intercontinental presence, intergeographic presence, you never know, you may be interacting with someone who's based in the US, UK, Sydney, anywhere else, and English is the universal language. I would perhaps need someone who's an excellent communicator, not just in speaking, but in writing as well. So in summary, yes, technical skills are required to an extent that I'm not looking at someone as a Shakuntala or an Aryabhatta, but I would look at someone who's got basic knowledge of statistics, principles of statistics and probability. That's one. Coding, yes, I would expect someone to have basic knowledge of coding, the startup knowledge of Tableaus or R's or Pythons of the world. That's enough. But yes, when I'm looking at individuals, that's second. The third is the business knowledge. Fourth is the communication a bit, and the fifth is the storytelling. One thing which is, there's one trend that's actually shaping the industry right now is very interesting, and that is, historically, companies had an appetite only to hire individuals belonging to the same sector. So as an example, if I work in a banking setup, I would only hire individuals who have had prior experience in banking. But the interesting part is that trend's changing now. Today, companies are more interested to hire someone from a non-banking setup. So I would perhaps want to hire someone from a pharmaceutical background or an e-commerce as opposed to banking. And that's only because the way data science or the entire AI or analytics ecosystem works is whatever models you create are agnostic of industries and verticals. But what really happens is when we start building our experience in, as an example, in banking, our thought process gets slightly siloed between, within the overall banking setup. I recently hired, a colleague from a pharmaceutical, setup, and we were trying to design a model which actually and the aim of the model was to predict the end state of the profit and loss account. And we used the model that this guy had used in the pharmaceutical industry, and the accuracy was 99%. For only one reason, because he said that this model was used in the previous organization for defining the success of a clinical trial process. So that's how the compatibility of the models are across the verticals and industries.
So I think cross-domain is now becoming popular, so people can move across domain very easily, provided you have the attitude and the aptitude to kind of get into that particular domain. So thank you for that answer, Anish. I think that makes a lot of sense. And now, especially coming to some experienced folks. Okay, so let's say project manager, program manager, general manager, HR managers. What do you think is their one? How can they use data science? And two, what do you think is their contribution in a data science team or data science organization, whichever way you want to look at it?
So let me answer the first part of the question, which is what can they do with data? I think, as I said, every function today has an ability to tap the data. Now, if it's a marketing side, the function has got an understanding of what are the sales from a marketing perspective, what are channels of marketing, what's the efficacy of. So a marketing guy, basis data, can study the efficacy of the marketing channels. That's one. Basis that, customized marketing campaigns can be designed. From a sales perspective, the region of sales, what is the sales, what is the demographic of the customers buying, that's where data can help. HR analytics or human capital analytics apparently are picking up the pace right now. Not limited to just the attrition number, and that's how we'd always understood HR data is okay. HR's got data; they can come back with an attrition number. Today, HR also has the ability to define the learning parts of an individual, basis the academic qualification, to define and predict the performance of an individual as well, basis the past performance. Define the ability to learn and design other interventions as well. Manage underperformance and manage top performance as well. So it's all about what's your appetite toward and how deeply do you look into the data. The relevance of all these support functions is immensely important, because end of the day, a data scientist is still a part of a wider ecosystem of an organization. Now, if as a data scientist, I'm not getting the right support or intervention from a learning perspective, not getting the right view from an HR perspective, and let's say if I'm a marketing in the marketing domain, if I'm not getting the right tools, I think I may not be having a good and fulfilling career with the organization.
Wonderful. So I think, yeah, this totally makes sense. Like, not only are you a person who can really use data, but you're also a person who can organize data and help your company succeed overall. So, Anish, I think I'm almost close to 12 o'clock. I've utilized almost the full time, but before we part, one last question to you.
Sure.
So this question is about if you suppose you are that 21-year-old young lad who's getting started into the world as a fresher today. So how would you carve your path down the line, and what should your strategy be? And let's also keep the COVID aspect in place as well.
Absolutely. My very first step would be to get clarity of what exactly do I want to do within the overall data analytics ecosystem as well. As I mentioned in the presentation, within this entire ecosystem, there are a number of roles. So there's a role of a data engineer, there's a role of a data analyst, there's a role of a data scientist, data visualization expert. I would first try to see clarity, what exactly is my focus on, what is it that I would probably want to do, because all these roles are completely different. So once I have that clarity, I would then try to pick an intervention which actually will help me to support. Now that intervention could be of multiple types. If I have a lot of time, or if I don't want to pursue a career right now, I just want to pursue academics, I would perhaps look at least a 2-year postgraduate course in data science or AI or analytics. That's one. If I want to continue my learning with my professional journey, I would perhaps be looking at a 6 month or a 12-month, intervention, which I can pursue while I'm working as well. That's the second bit. The third bit that I would perhaps want to do is I would set up alerts on Google using the keywords of AI, machine learning, and data analytics, because personally to me, these have been immensely helpful. It helps me to stay up to speed with what's happening in the industry. And these articles really help me to get a real-time knowledge of how companies are using these tools and technologies. That's the third bit. Fourth, I would try to create my profile online. And the profile is not just about sending invites on LinkedIn to people, but I'll try to create my own LinkedIn a LinkedIn aura. This is sharing my thought leadership, trying to interact with individuals, attend virtual events like these to get a better understanding from an industry perspective. And the last bit that I would perhaps definitely do is seek a mentor. So today there are a number of platforms which offer mentorship, and there is no cost involved to it. I think it makes all obvious senses to have a mentor in place, because a mentor gives you a very good independent perspective of what you're doing is right if you need any course correction. These are the quick ones for me.
Perfect. I think that totally makes sense. And thanks a lot for your valuable knowledge share that you did here. On behalf of all the 600 folks who are attending it live, and me and my entire team back here at INSAID, we extend our gratitude. We are really glad and we are really honored that you spent some valuable time of yours to educate all of us. So thanks a lot for that, Anish, and we would love to see you again with some more insights further.
Absolutely lovely. Thank you so much, Ajay. Take care.
Take care. Thank you. All the best. Bye.